Okay, and we're live. Let me know if you can hear me, if just to make sure that everything is well. Hi, everyone. We have some people already joining. How are you? Can you hear me well? Let me know in the chat so I'm sure that everything is fine. Okay, cool. So, hi everyone. My name is Maria. I am your host for today. I am from Porto, Portugal, and there's also where I work at the Experts in our office in Porto. So, while we're waiting for everyone to join, let me know in the chat where you're from so we can see where everyone is right now. I'm always super curious to know who we're reaching and where. So, let's see. I can see that we have some people from Porto already. Nice. Georgia. Yeah, we also have some people here from Georgia. There's some people from Romania. That's nice. Nice to know. Welcome, everyone. Porto, Portugal. Great. We always have more people from Georgia, Portugal, and Bulgaria, which are where we have our offices. But it's always nice to see people from different locations. Nice. Georgia as well. Well, we have a lot of people from Georgia today. Wow, that's nice. We do have an office in Georgia, more specifically in Tbilisi. Yeah, from Porto, Georgia. Yeah, Georgia today is definitely winning. Okay, Switzerland. Okay, that's nice. Serbia as well. Nice, nice to know. German. Oh, okay. I guess this one is for you, German. I was reading. I thought that someone was going to say they were from Germany, but apparently they were just saying hi. Okay, that's nice. We have a lot of people from a lot of different places. It's always nice to see. Georgia is leading, so that's nice. I hope that you're all excited, that you all are ready to learn. Um, Bulgaria as well, finally. I was missing people from Bulgaria. We have, as I said, an office there, so we always have more people from Bulgaria, but today I was missing you guys. So nice to know we have some people from Bulgaria. Welcome. Welcome everyone. So we have people from a lot of places. So welcome everyone. And I guess we can start. I will just welcome you, and our speeches will start in a minute, so there's still some time for people to join. So, welcome to dxTechTalks. They are a series of free tech meetups that we organize here at DevExperts. And if you don't know who DevExperts is, we are an international fintech company, and we specialize in the development of financial software solution and services for just global markets in the capital markets industry. We started our activity in 2002, but the company has grown a lot since then, and we have R&D centers across the world in Jersey City, in Porto, as I said, Vilnius, Munich, Dublin, Tbilisi, Sofia, and we also have one in Istanbul. We started this project, dxTechTalks, so we could be closer, more in touch with the tech community, and just share our expertise in fintech, discuss our projects, our technologies, our tools with everyone. We have tech communities in Portugal, Bulgaria, and Georgia, because as we said, those are the offices that we have the most people in. So those are also where we have like the biggest tech communities, and those are where we organize offline meetups. But we also organize sometimes these online dxTech Talks, which we always have a lot of fun because we always get to connect with different people from different locations. So that is nice. And if you don't want to miss any of our future meetups, you just have to follow us on social media. We're on meetup.com, we're on Facebook, Instagram, LinkedIn, and much more. So if you want to stay in touch and learn about some of our upcoming events, follow us to make sure that you never miss an announcement. Okay, so today we have in program two Tech Talks, around 25 minutes each. And at the end of each one, you will have some time to ask your questions in our chat. So if you have any questions during the talk, you can just write it down in the chat, and then I will just ask our speakers. So let me introduce you to our first speaker. Viktor Isaev is an enterprise architect here at DevExperts. He has more than 20 years of software development experience in a lot of different roles. Viktor has worked in different companies, from startups to big enterprises, so he has a lot of experience and he knows what he's talking about. And he also believes that architecture is only 50% technology, and the other 50% is about people and processes. So now, together with Viktor, we will discover some practical ways that we can foster continuous improvement and keep organizations competitive without putting its operations at risk. So, Viktor, I welcome you to the stage.
Yeah, thanks, Maria. Hello, everyone. My name is indeed Viktor Isaev, and today in this brief talk, we're going to discuss the culture of experiments and innovation in our company and in general. So, yeah, let's first look at what we are going to talk about. So there is this innovation versus preservation trade-off, which is like, what are you going to do? Are you going to innovate heavily, or are you going to rest on the laurels and use what's proven by time and just do nothing fancy? What's the best thing to do, and how you can break your business with both innovation and the lack of innovation. That's going to be fun. Then we're going to review the DevExperts internal experiment framework, which is designed for running the experiments and doing innovation in a safe way. And after that, we're going to discuss, in general, the culture of experiments and this approach to trying something out before fully adopting it and using the full scale. All right. So innovation versus preservation, right? This is how I call it. And maybe that's not the widely used term, but still. This is a Chinese curse. May you live in a time of change. Change is hard. Change is dangerous. It's easier to be with something that is proven by time and that you already are familiar with and know well, rather than trying something new, because who knows, in these new things lies maybe some danger or some failure, probably. Nobody knows, right? And if you're doing a lot of changes, you actually have a lot of risk. I wonder if any one of you know this gentleman and recognize him. You can write in the chat maybe, just quickly. Maria, has anyone guessed who this gentleman is? I would not spend much time on that. His name is Nassim Taleb. And he's a famous man. He's like a self-made person, a very, very successful investor, financially independent, and he's very free to speak his mind. And what he speaks and talks about is often controversial and maybe even like sometimes offensive. But he has written a number of books, and the two most famous ones are The Black Swan and Anti-Fragility. And there are a lot of interesting thoughts in these books. And for our today's talk, there is an interesting thought in his Anti-Fragility book, which says the following: the expectation of a remaining lifetime of any particular technology equals the time it existed to date, right? So the longer the technology has stayed till today, uh, the longer it's gonna probably last, right? And the opposite is true. If the technology lives for 1 month already, the expectation is that it's gonna live just 1 month more, and that's it, right? It's just an expectation. We are speaking about the probabilities, but the idea is that you like do not underestimate the power of old, because old is proven by time, old is known to work, and old has survived many changes, many complex situations on the market, and we are operating in a complex competitive market. And once it survived, you better stick to it, right? And there are a lot of examples of breaking things with innovation. And there are like several categories of this happening, including the bad acquisitions or mergers, when one company purchases another for some reason to make their business better and it fails. Switching to an unreliable vendor. So you switch to a new vendor instead of old one. This vendor turns out to be just wrong, or it turns out to like be in fact your competitor, and it breaks your business down. Failed HR strategy moves, everything related to people. If you make significant changes, you are at the higher risk, because people is like it's a complex topic. The human organizations are complex, and many changes you probably want to make there may have unpredictable outcomes. Fruitless inventions with high budget. So you invest a lot of money in something that's gonna make your business fly and soar, but it turns out it's not the case. And you spend a lot of money and have actually zero as a result. And making this all or nothing bets is particularly risky and harmful. And there are actually many more ways to break a business with innovation. Let's briefly, quickly review some of the cases from some of these categories. So failed HR strategy. There was a company called Circuit City, a famous one. And in attempt to innovate their labor model, people-related thing, right? Circuit City fired experienced, high-paid sales staff. And as a result, they had to go bankrupt. Relying on a vendor, Borders company, in early 2000s, instead of building their own e-commerce platform, they relied on Amazon, which turned out to be their direct competitor, and they failed. Fruitless, expensive inventions, a platform called Quibi, and like their product called Turnstile. It's a viewing feature for like cleverly viewing videos, but this feature turned out to just not be useful, and it required a lot of investment and turned to nothing. Bad acquisitions. Sears company made several acquisitions like Kmart and various others, but it didn't didn't fire off, and it didn't bring them the expected results, and they had to go bankrupt. Okay, but the thing is that lack of innovation may kill you as well. So if you decide to just stick with something that is proven by time. Some companies that are more innovative may like just be ahead of you and leave you with nothing. And I have two stories for you. They will look probably similar. First one is the Kodak story. Kodak was a very famous company, and a lot of cameras and films by Kodak. It was a big share of the market. They actually invented the first digital camera in 1975, but like they failed to make this technology work for them because Kodak was a tape film company, and when the digital cameras came to market, they underestimated the importance of this technology and how far it's gonna go, and they also feared that the developing the digital technology going to eat their core business. But once they realized that it's just inevitable future, they failed to embrace it. And the market was already far ahead when they started to develop the digital business line. And the business model for developing digital was misaligned. They failed badly to develop it. And finally, in 2012, they had to go bankrupt. Okay. Polaroid. Actually, similar story. Polaroid was a camera company, and at some point they developed by that time's fantastic device, the instant photography. So huge camera, you press the button, and in a minute you get a ready-made photo. It was like, it was wow, it was future. But again, digital photography came to market and slowly but inevitably brought them to their knees because again they relied too much on this fantastic technology of making instant photos and failed to diversify their business and embrace this digital technology. Their efforts to embrace it were uncoordinated and underfunded, so they did not invest enough money to actually jump onto this technology. And as a result, just like Kodak, they had to go bankrupt. So when you innovate, you are at risk. When you do not innovate, you are at risk. And just like in famous citation from Alice in Wonderland regarding the innovations, so to stay on one place, we have to run, and to move anywhere, we must run just twice as fast. So what do we do actually? Do we innovate or not? How do we go about it? And how we make sure our business does not get like broken by either innovation or lack of innovation? This is what my second part is about. And here is our dev experts take on this, I would say, part of the take. And this is dev experts experiments framework. So what is an experiment in terms of this framework? By framework, I mean the set of processes and activities, right? So an experiment is a time and budget limited activity aimed to test a certain hypothesis. So we assume something, we assume some tool could be useful or some approach could be useful, and we need to test that on a limited scope. So as I said, hypothesis could be testing a new tool, testing a replacement or complement to an existing tool, or testing a process. There is a life cycle in any experiment. Any experiment has a life cycle. So first it gets suggested, then it moves to initial review state, then it gets prepared, then we start running the experiment, then we go to final review, and then we finish the experiment. And I'm going to explain each of these phases in more detail. But first, what's the possible outcomes of the experiment. So we run an experiment, we finish it. What could be the result? One of the possible results is a positive result, which means we have confirmed the hypothesis. It also could be negative. So it means that we checked the hypothesis and we verified that it's not correct. And an experiment could be canceled as well. So we decided to not move forward with an experiment for the reasons of the lack of budget. It takes too much money to run an experiment, or for the reason of not having enough time or not having enough I don't know, capacity to run an experiment now or in any foreseeable future. So we could cancel a suggested experiment. But anyway, each suggested experiment gets reviewed. I'm going to explain it in a moment. How do we start an experiment? The thing is, anyone in our company, in the experts, can suggest an experiment, suggest an idea to try, right? And it's a matter of just clicking one single button, which is propose new experiment. And when you click this button, you become an initiator for the experiment. And your job is to fill in the form with so-called presentation, which explains the idea, explains its business value and usefulness, possible usefulness for the company. There is a small screenshot. It's not probably visible enough, but the idea is that there is some form with few fields that you need to fill in to explain the idea. And once your presentation is ready, boom, the experiment becomes suggested and you're done. And then after the experiment is suggested, it goes to the experiment committee, which is a team of experts, technical or business experts that who review the experiments and move them from suggested to initial review state, and then decide whether we go forward with this experiment or not. And the committee also decides, besides that they recognize if the experiment has value or not, they also estimate the time and money budget for the experiment. So how much money and time would it take to run an experiment, and the time frame for the experiment, because this is an activity limited in time. Typically it's up to 6 months. And the committee checks if the value is worth the budget. So is it worthwhile to check this idea given the budgeting constraints, right? If it's not, the experiment gets canceled, of course. But if it is, the experiment moves to the preparing state. And the committee assigns a facilitator for an experiment. A facilitator is a person that moves the experiment forward until it is finished. So preparation of experiments could take really long time, actually, because it could require a lot of activities. It could require preparing environments, buying licenses, negotiating the purchase of the licenses with the finance department, with the legal department, so that they approve legally if it is possible to run, for example, this tool with our private data, things like that. Are the agreements correct? Runs all the possible communication and discussions about running the experiment, notifies everything, everybody, finds people to run, to participate in an experiment if the experiment involves a certain group of people, the ones who will be trying out the technology. And of course, carefully records all the observations and gathers all the possible materials during the experiment, because everything collected during running an experiment is super important, because it influences the final decision. So once the experiment is prepared, it starts running, and this running phase is limited by the period of time that was initially agreed upon. And during experiments, we collect textual notes, video recordings, maybe some metrics, discussions, and everything we could collect to understand how the idea is working, uh, how it actually works. And finally, uh, when the time has passed, the experiment moves to the final review stage, where we analyze all the collected observations and, which is probably even more important, we poll the participants for their feedback and for their feeling and opinion about what have they seen and what is their experience with the new idea, technology, process, or tool. And then we present the results to the decision makers and make the final decision if it's positive or negative, right? So what does positive mean? Positive means that we understand that the hypothesis is correct and the idea could work out. It's not necessary that it's going to be our new tool adopted all of a sudden, but it means that we have like a good arguments or like we have something that proves the correctness of our hypothesis, and we have a reason to really move forward with this thing that we have tested. But also, it could mean that we need additional experiments to be more confident in the results or to test some additional hypotheses that provide us with more information to make the better decision. And as I said, positive does not mean that we adopt the technology right away. And also, it does not mean that we immediately throw away the existing counterpart. We do not operate this way, and we don't want to. We want to be careful and go step by step all the time. But the experiments and the positive outcome makes us a little bit more confident that we're going to succeed with this, right? And after the experiment has finished, we have some number of real people who have real experience with the new technology, and they have the context. They can explain why it works and why is it good and why is it better, which is more important. Why is it better than something that we already have? And having that said, I will slide to the more general topic of the culture of experiment with a little bit more of philosophy here. But the culture is even more important than any framework. Culture is about how we think and how we operate every day, all of us. All life is an experiment. The more experiments you make, the better. Very, very correct. And the culture of experiments actually encourages us to test more and to experiment more without being afraid of failure. Because during the experiments, you are free to fail. That's an important thing. So no one would ever like be hard on you because of your failures during the experiment. The negative result is also an asset, right? And the culture of experiments tells us that we need to try new things all the time, but at the same time, we need to respect the proven things, right? Respect what already works and try not to break it. And to deal with the existing stuff that is proven to work, we need to understand why it is there. We need to understand the reasons to be for the existing technologies and approaches. And for this, we need a really good knowledge base and documentation, because this knowledge base and documentation at any given point in time should give us a clear answer. Why are we doing it the way we do, right? And we need to question the current approaches all the time. So why are we doing it this way? Because the environment changes all the time, and what is correct today might be incorrect tomorrow. Recall these Kodak and Polaroid stories. Um, Embrace innovation and at the same time fight bad ideas. It's important to really to recognize bad ideas and not let them go forward, because they can ruin your business. So we need to discuss and experiment all the time, and we need to communicate and discuss in the correct way. And there is some number of blacklisted arguments that shouldn't be actually used when you discuss innovations, and you can see those. I won't even read them out because they are kind of well known. At the same time, there are whitelisted arguments, and some of them, I would say all of them, are absolutely valid. And we need to understand why things are done like the way they are done, as I said. What's the business value of the change? You shouldn't be doing any innovation without understanding what's the business value. The innovation for innovation is kind of a bad way to go. Who's going to pay for that? Our favorite question in our company, because it's not enough to just launch the innovation. Somebody is going to support it, and who's going to support it, and how much would it cost? Because you're gonna use it daily, and you're gonna spend effort on this daily. And is the effort worth the benefit? Right? You need to understand that. Um, and finally, with the experiments framework and the culture of experiments, here is like the big picture of what we do to embrace innovation and at the same time to not be broken by innovation. So suggesting ideas, testing ideas, applying these ideas gradually, and then again suggesting the ideas. Two big ideas maybe at a time, the ones that whoops the ones that give you potentially a 10x improvement, and many small ideas that give some improvements that are more useful than not, and that have certain business value, which together will probably compound and again make a 10x improvements one fine day. Okay, summary. What have we spoken about? The trade-off between the innovation and preservation, right? The experiments framework and the importance of the culture of experiments. Stay hungry, stay foolish, as Steve Jobs said. Always question things. Always act like it's day one, right? And embrace innovation, but respect proven things. Thank you so much. And with this, I welcome your questions.
Thank you so much, Viktor. That was a great talk. Congratulations, as always, of course. But yeah, it's very clear that, balancing stability and innovation can be a big challenge that a lot of companies face. And these strategies are not very spoken of most of the time. So thank you for giving us this practical overview that allow organizations to evolve without then jeopardizing what already works. So let's move on to our Q&A, shall we? So the first question that we have here is, who should be a facilitator and what skills should this person have?
Yeah, a facilitator is an example of so-called glue work, right? So this is a person who runs a lot of communication and glues the people and processes together to make things move forward. And particularly in case of facilitator, it's the job of moving experiment forward, which is a complex activity, involves a lot of people. So this person should have, of course, great communication skills. At the same time, this person should clearly understands the structure of a company, who is who does what, and who are the right people to communicate with, and how to connect these people together. Also, this person should be capable of speaking with vendors, discussing the maybe agreements about the purchasing of certain products to try, discussing things with legal and finance departments, and well, discussing various topics related to the business of the company. And of course, understanding the idea itself and what's the value of the idea, and having the proper motivation to move the experiment forward. Something like this. And typically it's senior engineering, staff plus engineering guys or girls, or somebody from project management, probably, because project management is a very similar activity of moving things forwards. I would say like this.
That's great. We do have a few more questions. So two of them are about AI. So I will just start with the one that is not, so then we can aggregate all of the AI. Are there any basic methods or approaches for conducting experiments?
Basic methods for conducting experiments. Well, actually, what we have inside DevExperts is our homegrown framework, and but still it's kind of very flexible, because the variety of experiments is really high. On one hand, you could be testing certain tools. On the other hand, you could be testing ideas with processes or some dramatic changes in your company on a limited scope. And these would be very different experiments. And there is no single methodology to rule them all, I would say. But for testing the tooling or instruments, there could be some methods of properly running this with a limited testing group, like comparing it to some reference group, maybe. We are not that deep into this yet, and we don't use any formal scientific methods, but maybe it's going to come. We'll see. Right now, our purpose is to just be confident and aware that certain idea works out and certain idea does not. And we heavily rely on our very smart colleagues on that. And if they give feedback, which is usually a sizable one, about how good an idea is, we tend to believe them, as well as in the case when they explain why the idea is bad, right? So we rely on people mostly during our experiments. Right? There is also a possibility sometimes to rely on metrics, but it's a more rare case, in my understanding. But there is there are certain cases when we also use metrics, and German is going to tell about exactly such case.
Okay, that's great. Thank you. So we do have some AI questions. Someone asked at the beginning of your presentation, actually, speaking of AI, there are a lot of languages, GS, Java, and so on. Are there any new languages that AI created?
the languages created by AI, I'm not aware of such yet, but I heard news that there is already a language developed for AI engines to communicate with each other. It's like more efficient than the human textual language, and it's based on the vectors from the embedding space. That's all I can say.
Okay, that's good. The next one is, how will AI and automation shape the future of experimentation in software development, and what ethical boundaries should organizations consider when innovating at scale? It's a big one.
Huh. Experimenting using AI. It's hardly imagined today. It's hard to imagine today how it's going to happen. But actually, some years ago, it was hard to imagine how AI could program, right? Um, I would, in this respect, I would rather think about things like LangChain and building certain basic logic of running experiments given the presentation, the description of an idea, right? And LangChain is about gluing various AI agents together to perform a certain complex activity with branching, looping, and things that we are familiar with in like program design, and is gonna operate like a huge business process. If anyone is familiar with BPMN and describing business processes with a visual language, automating the business processes, I would think about something similar, but AI based, right? And in these huge blocks, the process moves from one to another. The blocks are actually AI agents, each performing certain tasks, giving certain output, and depending on the output, there is like further logic, which is again performed by the the AI agents that follow. For example, I could imagine an AI agent that invites certain people to be the experiment participants based on some heuristic whether these people fit or not and why is that, right? And explaining why they invited exactly these people to participate in an experiment. And similar other steps. Collecting the feedback could be automated probably. There are many ways many room for automation here, and that's the interesting idea. Maybe someday we're gonna take advantage of such an approach. What's speaking about the ethics? My take on it would be limiting the scope and the possibilities of these agents as much as possible. So, like Unix way, do one thing well, do nothing else, right? And
Okay,
in this case, you are kind of safe, probably. But
nice.
is a keyword.
Yeah. Thank you. So unfortunately, we don't have more time for questions. I do see that there is one left, but would it be okay, Victor, if people reached you out on LinkedIn or something for doubts?
Absolutely, absolutely.
Okay. So you can find Victor on LinkedIn and just send him a message with your doubts, and I'm sure that he will answer. Thank you so much, Victor. This was amazing. As always, you're an amazing speaker. Thank you for letting us know everything about just innovating without breaking things. So now we're actually moving on to our second speech, which is just as interesting. And our speaker is Tebiev, who is a software engineer and has 10 years of experience. In the past year, German dove deep into AI, and he promoted its usage among dev experts engineers. So today, German will share how to measure the success of AI in software development. So today, German, please, I welcome you to the stage. I know that there's a lot of people eager to hear about AI, so please take the stage and good luck.
Okay. Can you hear me well?
Yep, everything is good.
Yeah. Thank you, Maria, for sharing microphone with me. Let me dive into the topic that I prepared. Viktor proposed you that we should dive into experimenting, and while listening to his speech, I already did prepare the presentation, and here it is for you just to know how is it to experiment, how to apply this knowledge. So let us start with figuring out on how to measure the success of AI implementation in software development. You know, everyone, now, let me first tell about me. My name, as already said, is Tebiev. I have 10 years of experience in software engineering. In DevExperts, I am since 2029, and currently I work on introducing AI pair programming into DevExperts. All different kinds of AI components, including GitHub Copilots, including Cursor, but more Viktor, but I already also do, including Windsurf and else. And when introducing these instruments, it's a question like, why do we do so? Why do we need to introduce instruments into life of our engineers? They already have lots of loads on their shoulders. Why should we bother them? Well, because it is said that AI companions, especially AI engines, but first we will talk about AI companions, significantly enhance developers' productivity. In the beginning of their introduction, GitHub Copilot claims that their solution could enhance the engineering's productivity up to 55%. And this is surely a cool gain. Just imagine if you have your projects completing twice as fast. It's very cool. But one thing is the promotional data, and another thing is real data. And we needed to discover it. We needed to figure out, do we gain this 55% experience increase or not? Let me jump to the next slide. The agenda for today will be the following. First, I'll tell you about the experiment structure. Next, I'll talk a little bit about the high-level GitHub Copilot introduction goals. Then we need to map these goals to metrics, and this is what we'll do. Then we'll discover what we found on the experiments, what were our discoveries. And as well, you will listen to our takeaways and decisions. Let's first start with the structure of the experiment. Our experiment was split into two parts. First, it was the leaf experiment with 5 participants, and it was 3 months of length. The second part was the retrospective analysis. There were 50 participants analyzed before starting to use Copilot and after it. Let's talk first about the leaf experiment characteristics. It was somewhere about 1 month of preparation. We were supposed to find the volunteers and to describe everything to them. We needed to ensure that they have 3 months of previous development experience so that we can compare. The experiment lasted for 3 months and we took somewhere around 2 weeks of our results calculations. We already had metrics gathering software in the place. And having it significantly reduces the time that you need to arrange an experiment. My manager was my stakeholder, and I was the one who conducted it. So we had 5 volunteers with 3 months of previously tracked development history, and we gathered these people via Slack. After doing the leaf experiment, we decided that we already have some data in our software that gathers the metrics, and we decided to look at it as well. It took us somewhere around 2 weeks. We had to agree on how to aggregate data. Once again, my manager was a stakeholder in the analysis, and I was the one who extracted and aggregated the data. As well as we use ChatGPT to create a program for gathering data by calling the API of the metrics gathering tool. Before starting the experiments, we had to agree on the goals that we would like to have for the GitHub Copilot to measure, do we reach these goals or not? We had several of them, and first we had productivity goals. First, after introducing GitHub Copilot into the workflow, engineers should code faster, won't they or not? Engineers should also complete more tasks, and they should maintain the code quality. We don't want to throw any piece of code that seems to work into our code base. Also, we had several risk factors. Code size could significantly increase, and we should somehow mitigate it. And so we could also see the increase in their work, which was about fixing the AI-generated code that was overlooked while initial development. When having these high-level goals, we can still measure them, and we need to somehow map these high-level goals to actual metrics that we can track, that we can see, that we can calculate. So the high-level goals needed clear, trackable metrics. They should reflect speed, productivity, and code quality, as well as these high-level metrics should reflect the potential risks. How do we measure speeds? We measure speeds by several metrics. First of them is cycle time. It's time from the first commit to the time when the PR was merged. The time to open in our case was the time from the first commit to PR creation. Time to merge is the lifetime of our PR. And also we looked at discussion cycles. It's the amount, or the number of iterations that our engineers took to complete this review. Now let's talk about productivity and quality. Our goal was to have more tasks completed. How do we measure them? Yes, we count them. This is called also the PR throughput, number of merged PRs over time. We also wanted to maintain code quality. We had 3 metrics to do so. First of them is innovation rate. It's the percentage of code that is brand new. Another metric is maintenance rate. It's the percentage of the code updates of older work, which is older than 3 weeks. And the rework rate. It's when you come to code that you wrote a week or 2, less than 3 ago, and fix it so that it works well. What could go wrong? Let's talk about the risks. The PR size, which is measured in the lines of code, could significantly increase. And once again, looking back, here we have rework rate, and here we have rework rate. But in first case, we want it to be stable, and here we saw a risk of its growing. How did we measure the metrics? We retrieved some data from GitHub, the velocity tool that we used at the moment, and some of our internal tools. We used the API queries for retrospective analysis and designed aggregates to avoid distortions. And what did our metrics reveal? For leaf experiments, we didn't have any significant speed increase, but we had, well, decent productivity gains. For retrospective analysis, we have contradictory results. Something like we worked faster, but did less. What challenges did we face while doing the leaf experiment and retrospective analysis? Well, in the first case, it was small sample size. For 5 engineers, anything could happen that would distort the data that we gathered, so that GitHub Copilot is no more a significant variable, but something else. Also, we had external variables, as already said, which could be more important than GitHub Copilot. And it turned out that GitHub Copilot is not super intuitive. You have a learning curve. After doing so, after conducting the experiments, we have to improve the future of our experimenting. We have to learn and do the experiments better. So what we plan to do? we plan to expand the pool of our participants. Like 5 engineers is not enough. 5,000 is great, but we don't have 5,000, so at least we need to have more than 5. Maybe 10, maybe 50 would be even better. We should refine metrics for better isolation of Copilot's impacts. The first improvement that we surely can do to our metrics is to stop calculating them from the beginning of the first commit, but to start measuring them from the time when the actual task was taken into the work. Also, we need to consider additional qualitative data, the thing that is called also the developer's feedback. And we already do. We send questionnaires every several months and ask people how much time saving do they feel because of using the AI tools. In September of 2024, there were somewhere around 60% of people saying that they feel not significant, but some time uh, uh, savings. And in January, there were already 80% of people who see time savings because of using the AI tools. Key takeaways. We can use metrics. What a surprise. Metrics help us quantify AI tools, real-world impacts. Copilot showed mixed results. It was productivity gains for the leaf experiment, and for the retrospective analysis, it was contradictory results. It's very helpful, but not a magic bullet. Well, maybe at least not everyone uses agents. Experiment design matters. Well, humanity already knows this. GitHub Copilot also has its learning curve, as already said before. We didn't expect it as it looks like enhanced autocomplete at the time when we tried to use it, but it turns out that there are features that are hidden for our engineers. For example, the inline chat, the special panel where you see all the possible results so that you can choose from, not just the one that you see at this very moment, and something else. Also, to help us mitigate this problem of not knowing and to educate our engineers, we came up with a dedicated learning course so that they can read it and understand what to do. There are 4 modules, and it's already integrated in our internships, which I'm for sure proud of. Let's summarize. We had an experiment which was built of 2 parts, the leaf experiment with 5 participants and retrospective analysis with 50 participants. Our goal was to improve speed, increase task completion, and maintain code quality. We used to measure the speed by utilizing cycle time, time to merge, time to open. There were also discussion cycles. We measured productivity with PR throughput and quality via innovation, maintenance, and rework rates. Also, we measured risks. We are the PR size, and once again, we looked at their work here. Key findings. No clear speed boost, but some productivity gains, well, actually good productivity gains for the leaf experiment. But once again, the sample there was too small. The retrospective analysis show conflicting results. And as already said, small sample size and external factors influenced outcomes. Future improvements that we can do. We can have larger participants pool, refined metrics, and qualitative developers feedback. Thank you. Now I am open for your questions.
Thank you so much, Carmen. Yeah, everyone loves AI. I mean, not everyone. Some people still look at it in a bad way. It definitely brings a lot of opportunities and challenges as well. Having this like structured approach to measuring its impacts is crucial. And understanding the right metrics helps us make also informed decisions and maximize the benefits. So this was a great talk. Thank you so much. We already have a lot of questions actually. So let me read them for you. First one, do you have plans for the NEO experiments with this knowledge at hand?
Yes, we surely have plans for new experiments. Now we need to, let's say, prepare our new matrix gathering tool, which was at place when we first were doing the experiments. And as I said, this helps a lot. And it takes some time to prepare this tool.
Cool, cool. And on what levels, what level of engineers experiment was this done?
They were volunteers, so we didn't choose any specific level of engineers, but as far as I remember, they were middle engineers and senior engineers.
Okay, that's great. The next question that we have is, how can we ensure that AI-driven software development improves long-term code maintainability rather than just short-term productivity?
How do we can ensure that it improves long-term maintainability? Yes.
Rather than just, okay.
Yeah, it's me repeating the question. In my opinion, you should document the rules for coding via linting, via formatting, like the ones that you can automate that, let's say, easily. And you also should write the documentation, the human written documentation on what coding rules or programming rules you have in your project, and to ask agents to read it and utilize it. Also, I would recommend saying something, here is the component or here is a class, look at how it is developed and create for me the class that follows the rules of this one. So it's two things that I can see now. It's the clear set of rules to put in your prompts to reference it, and it's referencing the already existing examples of the code that you see as high quality codes.
Okay, that's great. So we don't have any more questions as of right now. So I guess that everyone is clear on the topic. Thank you so much, German. That was amazing. And thank you everyone for joining us. So you should subscribe to our YouTube channel so you can always find our dxTech Talks. Also follow us on our social media. So you can always stay in touch and just know when our next dxTech Talks and events in general are going to be. If you want to talk at dxTech Talk, we have our landing page and we have call for papers there so you can apply. The link is available in the broadcast description, so you can just click and maybe become a speaker at our next dxTech Talk. Who knows? So, thank you guys so much. I will hopefully see you at our next dxTech Talk online, and for some of you also our dxTech Talks in person. Bye bye.
Thank you for questions. Thank you for listening.
Thank you, guys. Bye-bye.